Hi everyone, good morning. I am Chalini Nita, and today I am presenting my final year project titled Hello Scan Interpreting Hidden Status of Large Language Models for Fine Grained Hallucination Detection. In simple words, I build a system that catch AI mistake in real time and tell you exactly which word is wrong. So let me start by explaining the problem I'm solving. So I have a probably, it means like you have probably used ChatGPT or another AI system, right? So these systems are very powerful, but they sometimes say these that sound completely correct, but but are actually wrong, right? So this is called as the hallucination. For example, if you ask the AI when instance was born, it might say 1879 in Paris. Okay, so then so the AI says this confidently without any warning. So this is the serious problem, especially in healthcare, law, and education, where wrong information can cause real harm. So when I reviewed the existing research, I found two gaps that nobody has it means like fully solved it. So gap one is mostly detection system only analyzing the answer. It means like after the AI has finished writing the full response, by then it is too late. Okay, so the wrong information has already been generated, right? So second gap is most system flag the entire sentence or paragraph as wrong even when only a specific word is incorrect. So if you ask the AI about instance and it generate the year wrong, so this system flag the whole answer. That is not useful, right, to a real user. So my project address both of these gap. And next, actually my solution is this is called as the hello scan. And let me give you a simple analogy. Like imagine doctor who read your brain scan while you are thinking. Okay, not after you have spoken. That is exactly what HelloScan does. So instead of like waiting for the AI to finish its answer and then checking it, HelloScan watches the AI internal signals during the generation process. So and instead of flagging the whole sentence, HelloScan identify and highlight only the specific like wrong word, like a name or a date or a number, something like that. So I have achieved very fast processing, 896 millisecond on average. So my target was 5 second. So I am 5 point, so I am 5.6 times faster than the required. So these three things together, real time detection, exact word identification, and like fast speed, are what make HelloScan different from the existing methods. So next, I will move on to the I will go with the my pipeline architecture part. So now let me explain how the system actually works, like technically. It means like when a user type a prompt, so it goes through four modules in the sequence. So module A, this one, the module A, this is where the system identify what call exact answer token. So these are the words that could contain factual errors, right? So things like names, date, location, and numbers, like that. So I use a natural language processing tool called the SPACY to find these automatically. And then we have the module B. So this is the core of my research. It's like while the AI is generating each answer, my system listeners called PyTorch hooks to three specific internal layers of the model, layers 18, 20, and the 22. So these hooks capture the hidden state at each step, so which represent the model internal thinking process. So already we have done with module A and B, then we go with module C. So this module computes two signals from those hidden state. First was the Western distance, which measure how, it means like how much the AI internal representation has shift between layers, and the larger shift indicates uncertainty. And second, the truthfulness separator vector, a lightweight linear prop training to separate truthful activation from the hallucinated one. And then we have the module D. So the final module combine all the three signals: entropy, Weierstein distance, and DASV, so into one unified score per token. So it means like it then flag only the token that exceed the threshold. It means like the threshold and the exact answer token. So everything else is make safe, and the final output is color coded. It means like red for the hallucinated, and yellow for the suspicious, and white for the safe. So and it is show in the React user interface. And then I will go with the, yeah, now let me like show you the result of my project. So first, performance. So in the performance, my system achieved an average latency of 896 millisecond. My non-functional requirement was under 5000 millisecond, and so I satisfied this requirement with 5.6 times margin. So the second one is the second is the testing. So I wrote this one. So the 194 automated test. So 194 automated test, and 177 unit test, and 17 integrate test. So and all of them passed 100% pass rate. So the third, we have the detection rate. So on the trivia QA dataset with 100 question, my system flagged suspicious content in 67 out of the 100 response. So now let me address the F1 score honestly. So it's like my first one score with OPT 1.3B was 0.054, which is lower than I targeted. But here is the important finding from my ablation study. When I remove the EAT filter, the F1 jumped from the 0 to 0.148. What does this tell me? It tells me that detection signals are working correctly, right? So the reason the full system show a lower F1 is that the development model OPT 1.3B generates a worked answer. I think it depends that do not contain any names entities. So the EAT filter correctly find nothing to flag. And when I search to llama 3.2 3B instruct, which generate specific factual claims, the system targets exactly the right token. So this is the genuine research finding, so not a system failure. So then I will go with my contribution part. So in my contribution, so my research make three specific contributions to the body of the knowledge. So contribution one is like it's like a novel real time detection. It means like this is detect hallucination while model generating the answer. So I am the first to combine Wasserstein distance semantic entropy and truthfulness separator vector simultaneously in the single forward pass during generation. So existing method like self-check GPT require multiple generation passes, so which means they cannot be real time, and HelloScan does it one pass in under a second, right? So then contribution 2, so exact word flagging by combining name entity recognition with hidden state analysis. I can tell the user exactly okay which word is wrong, not just that sentence contain an error. So no existing published method provide both real time capability and expect word identification together. So the this is my second contribution, and my third contribution is this is like a open source research toolkit, because I have the published the complete system to GitHub, and like including the four modules, the API, React frontend, and the test, and the evaluation scripts also. So other researchers also can directly build on this work. So yeah, then I will go with what I build, right? So let me now show tell you what I actually built during this project. I implemented 4 detection modules in Python using the it means like Python using the object oriented design. So I built a fast API reset backend with 4 endpoints. I created the React frontend with 6 components, including the token display, a score panel, like warning banner, and the configuration panel. So I wrote 194 automated tests, all passing. So I set up MLflow for the experiment tracking with 18 logged runs, and I containerized the entire system like doing Docker, but actually I have to do it, but I'm still doing it. So and so all of these this was built over like like 2 months using like 15 git branches with daily commit. So yeah, so then yeah, then I will go with the so this is actually I have published my work in the ICTIS Thailand conference. So it was accepted and I was presented also. So it was like a literature review and future work proposal. So yeah, then I will move with the thank you part. So yeah, HelloScan successfully address both research gap identified in the literature. So the gap one, it's like a real-time hidden state analysis is confirmed with like 896 ms average latency. So the gap 2, exact word identification, is artifactually implemented and verified through integration testing and the ablation testing. So all like 194 automated test pass. So 16 out of 16 functional requirements are satisfied, and 10 out of 11 non-functional requirements fully passed. And then the system is fully open source and reproducible and ready for the future work. So particularly like completing the full evaluation with llama And yeah, so the thank you very much for the listening, and I am happy to take any questions also. So yeah, thank you.